Computational design is about design exploration. It gives us the ability to explore the many variations that are possible within certain concepts.
Sean Alquist. I'm a professor of architecture here at the University of Michigan. The focus of my research here is in the design and engineering of textiles.
My name is Jim Durham, and I own Quarra Stone Company here in Madison, Wisconsin. And we manufacture cut stone. This is actually one of the blocks for the Autodesk project, 6.5 tons. Since the beginning of time, people have worked with stone, and many of the techniques for working stone haven't changed since civilization started. Now, as computers and software become more available, the opportunities have just exploded. At Quarra Stone, we're very curious, and we like to work with architects and designers and artists who want to push boundaries and want to challenge us to be able to do work that hasn't been done before.
The Generative Design Pavilion is really meant to showcase kind of that connection between computational design and manufacturing. The idea was to create this seamless geometry, but actually generate it out of different materials. So it became interesting to create the base out of the solid monolithic stone elements, and then connect that to a very lightweight textile structure, which could actually still kind of continue the forms in a very seamless and smooth manner.
The conversation we're having with this is much more collaborative, much more direct, it's much more real time.
What's interesting is the one connection point where we've had to talk quite closely is literally the moment at which the two materials interface each other, and how do they design to that point, and then how do I design from that point.
Typically in our workflow, there's an absolute cutoff between the design software and the tool pathing, robotic, and the fabrication applications. In the case of the Autodesk Pavilion, there's no break between those two processes.
There's a lot of really manual, tedious things that we do now that once we have this kind of back and forth loop, we'll be able to make that process a lot faster. And for large projects where we have multiple pieces, we'll be able to plug in all the geometry and have it just generate all the tool paths for us.
This project showcases this ability to, even in a short timeline, go from the development of designing our own materials, tailoring them for a very specific design, and then actually implementing them in a full-scale installation. What I think is becoming interesting is the sort of future of making starts to really broaden not just the scope of what the architect or the designer is involved in, but also start to more intimately address the question of why are we working with materials in these ways, and being more critical of how it performs as an actual architecture.